So question number 3 on exercise 3 says, at what value of x does the function f of x is equal to x raised to power minus x and s belonging to real numbers, that is the values of x are values in the real number line, attained maximum? Solution. The function f of x, which is the same thing as y, is equals to x raised to the power of minus x. So what do we do at this point? It's simple. We are going to write this as y equals to f of x is the same thing as y. Y is equals to x raised to the power minus x. Now this is the type of function that is a variable raised to a variable, but the variable is actually negative, but actually it is variable over variable. And how do you differentiate a function that has to do with variable over variable? The easiest way to go about it is to take the ln of both sides. Take the ln of both sides. What does ln simply means? It's a natural log, which is log base e. So anytime you see ln, it's the same thing as log base e, and log base e is the same thing as ln. So that means that if I write ln x, it simply means log x base e. Ln alone is log base e, but ln x is log x base e. All right, so let's differentiate this function by one, taking ln of both sides. So that means ln y is equals to ln x raised to the power of minus x. Don't forget, ln means log. So that means that ln y is equals to, since there is log here, and you know that if you have log x raised to the power n base a, there is a power of log, that the power of the log, which is n, will come to the front of the log, and you have n log then x base a from the laws of logarithm, which is the powers law. So since this is a log, then I can bring down minus x. So I have this to be minus x ln x. Next thing is for me to differentiate from here. So in differentiating, you would have also learned before now that if you differentiate ln x, the answer, if y is equals to ln x, then dy over the x is 1 over x. Meaning that if you differentiate ln y, then the answer will also be 1 over y. But don't forget that differentiating ln y is like differentiating an implicit function. And that anytime you differentiate y, you must always introduce dy dx. So that's what happens here. The derivative of ln y is 1 over y dy dx, which is equals to, the derivative of minus x ln x is a product function. So this product, okay, this can be split into two now, say minus x and ln x. So a very simple way of differentiating product function is keep the first, which is minus x, times differentiate the second. What's the derivative of ln x? 1 over x, plus keep the second, which is ln x, times differentiate the first. What's the derivative of minus x? Minus 1. So that's how you differentiate the function there. Now, if you cancel this and this, that is x cancels x, it means that you have 1 over y dy dx equals to, I'm left with minus 1 here. So you have minus 1, okay? Minus 1 times ln x is minus ln x. So dy dx will be equals to, now 1 over y will move to this side and become y. That's primary forcing. If you do that very well, you will know. 1 over y, when it moves to this side, it becomes y. Okay? into minus 1 minus ln x. So it means that dy dx is equals to, I don't know if, okay, let me just do it in case. So the 1 over y is moving to this side. So you have minus 1 minus ln x all over. 1 over y moves and become 1 over y. Okay, so this is minus 1 minus ln x. Okay, times, don't forget that this is 1 over y. When this one changes to multiplication, y will go up and 1 will come down. So you have minus 1 minus ln x times y, which is y into minus 1 minus ln x, divided by 1, which is the same thing as that. So that's what I did to get this place. All right. Don't forget what y was. Y was x raised to the power minus n. So bring it back. So this is x raised to the power minus x. That is y is x raised to the power minus x. So carry this, put in the place of y. Okay, into minus 1 minus ln x. This is actually the derivative of this function f of x.